Welcome back to the deep dive. In our last session, episode 26, we really got into Aryabhata's Golapāda, didn't we?
We did. We focused on his arguments for Earth being a sphere Bhūgola, as he called it.
Right, round on all sides. And that really forward-thinking idea that the Earth actually spins.
Mm-hmm. Using that fantastic boat analogy to explain relative motion and why the stars seem to move.
Yeah, and we touched on how he placed Earth right at the center, Khamadhyagataḥ, and the Kadamba flower idea, explaining why we don't fall off. It was quite a lot.
It really set the stage, establishing his view of Earth's shape, place, and crucially, its movement.
Exactly. So today, we want to build on that. We're using episode 26 as a launch pad, really.
Okay.
We want to look a bit broader at Gupta astronomy, get a sense of the time Aryabhata was working in.
Good idea. Context is key.
And then dive deeper into his cosmic view, the sphere, the spin, but put it side by side with Ptolemy's model, the dominant Western view then.
The Ptolemy comparison. That's crucial for understanding the significance of Aryabhata's contribution, especially on the rotation point.
Definitely. But we're not stopping in the past. We're going to try and connect these ancient ideas to, well, right now.
Oh, how so?
Thinking about things like NASA, space travel, how GPS works, even VR simulations, and the whole philosophy of mapping the cosmos.
Wow. Okay, so bridging ancient insights to modern tech and thought. I like it.
That's the plan. See how these old ideas kind of echo today?
Sounds fascinating. It gives a much richer picture, placing Aryabhata in context, comparing him, and then tracing that line forward.
So let's start with that context, the Gupta period. We often hear it called a golden age for India. What made it so fertile for science and math?
Well, the Gupta era, roughly 4th to 6th century CE, was a time of relative stability and patronage for learning. This fostered real advancements.
Okay.
In astronomy and math, you see this trend towards more rigorous mathematical methods. Aryabhata is probably the prime example of that intellectual flowering. He wasn't working in a vacuum,
Right, part of a larger movement. And in that environment, he presents his cosmic view in the Golapāda. Let's go back to verse 5, those basic statements about Earth. What's he laying out?
Okay, verse 5. He starts with Earth's composition, the standard elements of the time. Earth, water, fire, air. And later, commentators added ether or akasha. Pretty standard understanding of matter then.
Mm-hmm.
But then, crucially, he states Earth's position.
Mm-hmm.
Khamadhyagataḥ, right in the middle of space, or the sky. And it's inside this circular cage of stars, and surrounded by the planet's orbits, Kakapidavita.
So very much a geocentric setup in terms of orbits, Earth at the center.
Exactly. That part aligns with the common view. But then he hits us with the shape.
Ah, yes, the kicker.
Bhūgola sarvatavita. The Earth sphere is round on all sides. That's not just an offhand comment. It's the geometric bedrock of his whole system. Everything builds from that spherical foundation.
And we know a round Earth wasn't obvious to everyone back then. How did he kind of ease people into this non-intuitive idea?
Well, in verse 6, he does something clever. He takes familiar geographical concepts and sort of maps them onto his sphere.
Like Maru.
Exactly. He mentions the Samanta Pravada, which commentators often link to the North Polar region, perhaps a reinterpretation of the mythical Mount Meru, placing it in the middle. And then down south, he places traditional concepts like Naraka and Bhattavamukha, essentially mapping them to the South Pole area.
So it's like saying, look, your traditional landmarks, they fit on this sphere, a way to reconcile things.
Precisely. It provides a framework.
Yeah.
And then to tackle the falling off problem, he uses that beautiful Kadamba flower analogy in verse 7.
Ah, yes. Remind us how that works again. It's such a great visual.
It really is.
Yeah.
He compares the Earth, covered in life, to a round Kadamba flower covered in blossoms, just like all the blossoms point inwards toward the flower center.
Everyone on Earth is oriented towards Earth's center.
Exactly. It beautifully illustrates a relative down. It's an intuitive grasp of the idea that gravity pulls towards the center from all points on the surface, so people on the bottom don't fall off.
Such an elegant way to put it. Okay, so we have a spherical Earth. People aren't falling off. But the really revolutionary part was his explanation for day and night, right? The moving heavens.
Absolutely. That's where he really departs from the mainstream. Instead of the whole sky turning around a fixed Earth.
We're the ones turning.
Yes. He proposes that the Earth itself rotates on its axis. Verse 9 gives us the famous boat analogy to explain this counterintuitive idea. It's all about relative motion.
The boat analogy. Still powerful. Walk us through it one more time.
Sure. Imagine you're on a boat moving forward. What happens to the trees and buildings on the riverbank?
They look like they're moving backward.
Right. So Aryabhata says it's the same with the stars. In terms of daily motion, they are the stationary riverbank, and we, on our rotating Earth, are the moving boat. Their apparent westward drift is actually caused by our eastward spin.
Simple, clear, logical. But as we said, not everyone bought it. What was the standard explanation he was pushing against?
The dominant theory, which Aryabhata himself mentions in verse 10, involves something called the Pravaha Vāyu.
The cosmic wind.
Exactly. This powerful, invisible wind was thought to constantly blow the entire celestial sphere, stars, planets, everything westward around a completely stationary Earth. That's what caused rising and setting in that model.
So, giant cosmic engine versus just us spinning. It's quite a contrast. And there was pushback.
Oh yes. Later on, Bhaskara I championed Aryabhata's rotation idea, but others, like the very influential astronomer Brahmagupta, strongly rejected it.
Why? What were the objections?
Brahmagupta raised practical points, like, if Earth spins so fast, why don't things fly off? Why don't clouds and birds get left behind?
Yeah, those seem like fair questions if you don't understand gravity and inertia.
Precisely. Those concepts weren't fully developed. So while Aryabhata had the right idea about rotation, the full physical explanation wasn't there yet, which made it easier for some to dismiss it based on everyday observations.
Yeah.
It really highlights how bold his insight was.
It really does. Okay, so let's pivot now and bring in Ptolemy. How did Aryabhata's cosmos compare to the big model coming out of the West around that time?
Right, Ptolemy. Active in the 2nd century CE, his work, the Almagest, defined Western astronomy for, well, over 1,000 years. His model was also geocentric.
Earth at the center, so agreement there.
On the centrality of Earth within the orbits, yes, both had Earth orbited by the Sun, Moon, and planets. But Ptolemy's Earth was absolutely fixed, completely stationary.
Ah, okay. So no spin.
No spin at all. For Ptolemy, all the daily motion, sun rising and setting, stars wheeling across the sky, was caused by the entire celestial sphere, the outermost sphere containing the stars, rotating around the static Earth once a day. He also had a complex system of epicycles and deference to explain the planet's weird retrograde motions.
So the big difference regarding day and night is Ptolemy has the sky moving, Aryabhata has the Earth moving.
That's the fundamental difference for explaining the diurnal motion. Aryabhata used Earth's rotation. Ptolemy needed the whole universe, essentially, to spin around a static Earth, a very different mechanical approach, even within that shared geocentric orbital framework.
That really clarifies the distinction. Okay, fast forward centuries. It seems almost strange to think these ancient models connect to modern tech, but you mentioned NASA.
Absolutely. Think about it. You can't plan a rocket launch or calculate a satellite orbit without knowing precisely that you're launching from a spherical planet that's rotating at a specific speed.
Right, the launch site itself is moving.
Exactly. Earth's rotation affects trajectories, orbital mechanics, everything. Understanding celestial mechanics, the physics of space, fundamentally relies on knowing Earth is a rotating sphere. Every NASA mission depends on it.
Wow. And GPS, how does that fit in? We use it constantly.
GPS is maybe an even more direct, everyday example. It works by timing signals from satellites orbiting Earth.
Okay.
To get accurate locations, the system needs to know exactly where those satellites are relative to the receiver on the ground at that instant. And because the Earth is rotating, your position as a receiver is constantly changing relative to those satellites in a predictable way.
Ah, so the system has to account for Earth's spin.
It absolutely has to. Plus, there are relativistic effects related to the satellite's speed and gravity. But the basic rotational movement is critical. If GPS calculations didn't factor in Earth's rotation, the location errors would be huge miles off pretty quickly.
That's incredible. So Aryabhata's spinning Earth is literally helping me find the nearest coffee shop.
In a very real computational sense, yes.
Oh, mind blown. Okay, what about VR? How could that technology help visualize these ideas?
VR offers a really powerful way to sort of step inside these different cosmic models. Imagine a VR experience where you're standing on a stationary Earth, watching Ptolemy's spheres and epicycles turn around you.
Okay, yeah.
Then switch to Aryabhata's view. You're on a rotating Earth, and now you see the stars appearing to move because you are moving. It could make the difference much more intuitive.
And the boat analogy?
You could simulate that too. Put the user in the boat, let them experience that feeling of relative motion directly, and then apply it to the stars. It could make these abstract concepts much more tangible and understandable. Really bring history to life.
That sounds like an amazing learning tool. Okay, finally, let's touch on the philosophy of it all. What do these different ways of mapping the cosmos tell us?
Well, I think both Aryabhata and Ptolemy show this fundamental human drive to make sense of the universe, to find order in the heavens. They observed, They reasoned, they built models to explain what they saw.
Trying to create a coherent picture.
Exactly. But Aryabhata's proposing a moving Earth, even if the orbits were still centered on, it represents a significant philosophical shift, doesn't it?
How so?
It challenges the assumption that we are the stable, unmoving center. It introduces dynamism to our own position. It raises questions about perspective, about relative versus absolute motion, and ultimately about our place in the grand scheme, thinking of ourselves on a spinning ball versus a fixed platform. That's a different psychological and philosophical stance.
It definitely changes your perspective on things. Okay, so wrapping up this deep dive, what are the main takeaways from looking at Aryabhata's spinning sphere against Ptolemy and linking it all the way to GPS and VR?
I think the main thing is the sheer ingenuity and, frankly, the correctness of Aryabhata's core idea about Earth's rotation.
Cool.
It was a radical departure, explained via relative motion, that ultimately proved right.
Even without the full physics explanation back then.
Right. And contrasting it with Ptolemy highlights just how different his approach to daily motion was. Then, seeing how absolutely fundamental that concept, a rotating spherical Earth, is to modern science and tech like NASA and GPS, it just underscores its enduring importance.
And the philosophical angle.
It reminds us that how we model the cosmos shapes how we see ourselves within it. The journey from a static Earth to a spinning planet is a huge leap in human understanding.
It really is. It leaves us with that thought, doesn't it? How does really knowing that you're on a planet spinning incredibly fast through space affect how you view your daily life, your place? Something to ponder. And for our next deep dive, episode 28, we're going to stick with Aryabhata. We'll explore some more consequences of his spinning sphere model, like how it helps explain time zones, essentially, and why your view of the stars changes depending on where you are on Earth.
Connecting rotation to latitude and observation. More fascinating implications.
Exactly. So please join us then for more insights from the ancient world that still resonate today.